Question 7 now, we are told that the Sweet Tooth Sugar Company has 2 production lines for the feeding of 1 kg bags, U1 and U2, with sugar. Using data collected over a long period of time, the production manager estimates that the population standard deviation of the wheat delivered for line 1 is 0.02 kilograms, and for line 2 is 0.04. A random sample of 10 bags is taken from line 1, and the mean weight in the bags is found to be that. A similar random sample of 12 bags is taken from line 2, and the mean fill is that. So is there any evidence to suggest that the 2 production lines are dispensing mean amounts? As you can see, there is the presence of delta. So that population is known. And again, you can see there are 2 samples. So in our solution 7, the population is known. So it's a known population. Known population. And then there are 2 means. So we are looking for means difference. So there are 2 in our equation, means difference. You want to get the difference between those 2 means. So in the hypothesis, the null hypothesis is usually written as the first mean is equal to the second mean. The first mean is equal to the second mean. That is the mean of the first sample was found to be 1.018, and the other one was found to have a mean of 0.989. So we are saying that they are the same. Then in the alternative, you say they are not the same and specify the direction. So you can see in this case, the mean of the first sample is greater than the mean of the second sample. That is 1.018 is greater than 0.989. It's greater than. Ukishasema that way, you proceed to tell us significance level. So once again, we shall let alpha to be 0.05. We shall let alpha to be 0.05. Proceeding on, we now get ourselves to the third step, which is called test statistic. Now the test statistic is given as Z is equals to X bar 1 minus X bar 2. You divide by standard deviation 1, which is divided by the square root of sample size 1 plus standard deviation 2, which is divided by the square root of the sample size 2. Sample size 2. So now from there, you tell us that Z calculated is 1.018 minus 0.989. This one you divide by the standard deviation of the first one is 0.02. You divide by the square root of 10 plus huyu mwingine, the standard deviation is 0.04, and the sample size is 12. So work out that in a minute, give me the answer. So what have you gotten? Point 0.02 divided by the root of 10 plus 0.04 divided by the root of 12 equals inverse multiplied by 1.018 minus 0.989, getting 1.623. So with that, we proceed now and get our decision rule. Our decision rule, which is 110, is going to be 110. And this one, again, because we are saying greater, we are going to shade from here, this side this way. So this is, you reject null. Reject null, which is, this is 0.05. Then here you accept null, which is 0.95. And because this is Z, it still remains what we had said earlier, positive Z critical as positive 1.64. So it still remains that way as 0.64. So that from there now you make the conclusion From there, you make the conclusion. And the conclusion is we shall accept null. We shall accept null since Z calculated is less than Z critical. That is 1.623 is less than 1.64. It's less than 1.64. Now, what does that mean? What does that mean? So, what that means is that the two machines, the machines are dispensing equal amounts. So they are the same, equal amounts. They are dispensing equal amounts of sugar. So on your own, you shall handle question 10. The numbering there is not very good. So you shall handle question 10 exactly the same way. Exactly the same way. So let's go to question number 11, which reads that a certain type of polymer is made by batch production. 10 samples and 1, 2 were taken from each of 2 consecutive batches, and the percentage of chemical X in each sample measured. For batch 1, the mean percentage per sample was 68.2% with a standard deviation of 0.7. For batch 2, the mean content of chemical X of 67 with a standard deviation of that. Is there any evidence to suggest that the 2 batches contain different percentages of the chemical? So again, as you can see there, there is no delta. There is no delta. So if there is no delta, that population is unknown. That population is unknown. And then you can clearly see that we have 2 samples. And that is question 11, so solution 11. Solution 11. I'm saying because we did not see the delta, our population is unknown. It is a known population. And because there are 2 samples, then we must be testing what we call means difference. Means difference. We are testing what we call means difference. So, in the hypothesis, I have told you that when you're dealing with the means difference, the null is normally written as x bar 1 is equal to x bar 2. That is, the first sample was found to have a mean of 68.2. Na huyo mwingine hapo na 67. 68.2 is the same as 67. Then in the alternative, x bar 1 will be greater than x bar 2, or is. That is 68.2 is greater than 67. It's greater than 67. Significance level. Significance level. The question again has not mentioned, so we continue assuming that alpha is 0.05. The next thing is called test statistic. Now this test statistic T is given as x bar 1 minus x bar 2, which is usually divided by the square root. It's usually divided by the square root of n1 minus 1 S1 squared plus n2 minus 1 S2 squared. This one is divided by n1 plus n2 minus 2. You multiply this by 1 out of n1 plus 1 out of n2. That is how you get it. Division is unknown and we're dealing with the mean difference. So when we come now to substitute, our T calculated will be 68.2 minus 67. 68.2 minus 67. You divide this by the square root of the first sample had they are saying 10 samples each. So this is 10 minus 1, and the standard deviation is 0.7 square plus 10 minus 1 multiplied by 0.74. You square that, then you divide this by 10 plus 10 minus 2. You come and multiply by 1 out of 10 plus 1 out of 10. So put those figures in the calc. You say 9 times 0.7 square plus 9 times 0.74 square equals, you divide by 18 times, that will be 0.2 equals, get the square root of that answer, then use it to divide 68.2 minus 67. And I'm getting 3.725. 3.725. After that, you now come and do the decision rule. The decision rule, it is 1/10. It is 1/10. And I told you when you are using T, the degrees of freedom should be brought on board. So the DF will be 10 plus 10 minus 2, which is 18. Those are the degrees of freedom. The DF is 18. So with that, you come and draw the table. Come and draw your table. And because your told is on the higher side, then we are looking for this one here. We're looking for this one. We're looking for this one. So if on this side, you will say accept null, which is 0.95. This is 0.05, which we are saying we reject. We reject null. Then here we look for positive T critical. Positive T critical. Positive T critical. So you go to the T tables, as I told you, because it is 1/10, utaenda kwa 95%, then uteremke kwa number 18. And in case you get a figure that the degrees of freedom are more than what you have, known as the figure that, in case you get more than that, you just take the highest. You take the highest, that is that. So, kwa 18, I have 1.7341. 1.7341. And it's positive. It is positive. So, my conclusion will be to reject null. To reject null since T calculated is greater than T critical. That is 3.725 is greater than 1.7341. Then we get the meaning. The meaning of that. Tulikuwa tunaulizwa whether they contain different percentages, and for sure you can see they are different. So they contain different percentages. It contain different percentages. So that is how it's done. You will do the same with question 12. Exactly the same. The formula is the same, so you just change the figures. Even with question 13. The only difference with 13 is that sasa utajitafutia mean ya group 1 na mean ya 2. But those questions are the same. They are the same, to me, the same approach. So that now I go to question number 14. Question number 14. Now in question 14, the internal auditors of a large company are interested in the system by which incoming invoices are processed. They take a random sample of 50 completed invoices and check them in detail for correctness of procedure. 4 are found to be defective in some way. The auditors then suggest some modifications to the procedure, and these are implemented. Allowing time for the clerks to adjust to the new procedures, the auditors then take a random sample of 60 completed invoices. This time they find 3 incorrect ones. Is there any evidence that the new procedures have improved the error rate? So again, you cannot see delta there in that question. There is no delta. So if you cannot see delta in that question, it tells you that the population is unknown. The population is unknown. So we are dealing with solution 14. Solution 14. And this is where we are saying that our population is unknown. And if population is unknown and we are given proportions, when you see the language of this out of this, and you can see they took 2 samples, then we are looking at proportions difference. Proportions difference. That is what we are looking at. Proportions difference. Now the examiner has not given us the proportions, so we'll have to compute by ourselves. So sample proportion 1. Sample proportion 1, we are told they got 4 in a total of 50. They got 4 in a total of 50. So if you are to take 4, you divide by 50, that gives you 0.08. Then in the second one, the second sample, they found 3 in a total of 60. They found 3 in a total of 60. So if you divide that, unapata 0.05. So that is how you compute. Now you begin the hypothesis. You begin the hypothesis. Hypothesis. You begin the hypothesis. Okay. So if you begin in the hypothesis, I've told you the alternative is always stated that proportion 1 is equal to proportion 2. That is 0.08 is equal to 0.05. 0.08 is equals to. Then in the alternative, now you look at the size of this. You can see the first one is greater. So you say sample proportion 1 is greater than sample proportion 2. That is 0.08 is greater than 0.05. 0.08 is greater than 0.05. Kama hiyo ndio ukweli, unakuja sasa unatafutia significance level significance level, we are not told. So again, we continue saying let alpha to be 0.05. From there, you tell us test statistic, how we shall arrive at it. So test statistic is always said, I've been telling you, anytime you see proportion, it is Z. Anytime you see proportion, it is Z, whether the population is known or unknown. So this one is given as sample proportion 1 minus sample proportion 2. This one, you divide it by the square root. You divide it by the square root of sample proportion 1 minus sample proportion 1. You divide by N1 plus sample proportion 2, 1 minus sample proportion 2. You divide this by sample size 2. Sample size 2. So putting those items in the calc or in the formula, Z calculated then should be 0.08 minus 0.05. 0.08. Then you get the square root of 0.08, 1 minus 0.08, plus 0.05, 1 minus 0.05. This one is divided by 50, and this one is divided by 60. Divided by 60. So we now come to group 4. Now come to look for the answer. So 0.08 times 0.92. We divide by 50 equals plus 0.05 times 0.95, which is divided by 60. I get the square root of the answer, then I reverse so that I multiply by 0.08 minus 0.05, and I'm getting 0.63. 0.63. Then from there, I come and give my decision rule. This decision rule will be one tail. It is one tail. And therefore, it shall be drawn like this. Shall be drawn like this. Because you are saying it's greater than. So here we shall say reject. This is 0.05. Here we are saying accept the null at 0.95. And because this is Z we have been talking about, that means you can even come. You can see they keep on repeating. So Z critical is 1.64. 1.64. So with that, we make the conclusion, and the conclusion is we will accept the null. We will accept the null since Z calculated is less than Z critical. That is 0.63 is less than 1.64. Is less than 1.64. Sasa tulikuwa tunaulizwa whether the new procedures have improved the error rate. And because you can see we have accepted the null, which says they are equal, then you simply tell us new procedures have not improved the error rate. Improve the error rate. So the new procedures have not improved the error rate. That is how we go about it. I think we are clear. Together. Okay. Now, the next thing that we need to discuss is called chi-square distribution. It is the one that is supposed to be used in the last two questions. So I will mention a few things, then we had one question. Possibly for it at that point. So chi-square distribution. And right, that this is used to test association of attributes. This is used to test association of attributes. That is, this is used to test association of attributes. Attributes. That is, items which cannot be quantified. Items which cannot be quantified. The test statistic used is sum of F naught minus FE square, you divide by FE where F naught is observed frequency. Observed frequency. Observed frequency. FE is the expected frequency. Expected frequency. And this one is normally given as column total multiplied by row total. Column total multiplied by row total. You will divide by the grad total or the entire total. Then you write that the degrees of freedom are computed as R minus 1 multiplied by C minus 1. The degrees of freedom are computed as R minus 1 multiplied by C minus 1, where R is the number of rows and C is the number of columns. So straight on, that is the much you needed to know. Like maybe you unataka kupima the smartness of a person and the honesty of that person or the goodness of that person. How do you measure that? So we are told in question 15 that the AutoSure PLC is a large insurance company specializing in car insurance. It has always been company policy to charge different premiums according to the size of the car being insured. The bigger the car, the bigger the premium. However, this policy is under review since branch managers have been reporting a higher rate of claim for personal injury for accidents involving small cars. One of the company's analysts has examined data from 566 recent claims. The data collected are shown below. So is there evidence that indicates that the frequency is of injury claims is associated with the size of the car? In simple terms, if you are driving in a Mercedes and someone else is driving in a Probox and both cars get an accident, will the level of injury be the same? That's what you want to answer or test in a question like that. So we are dealing with question 15. Solution 15. Now, first of all, add the small cars. The small cars, small cars, you add the medium, you add the large, wadike toto ya column na toto ya row. You write those totals. Then, we will come here and get the observed frequency. Observed frequency. And this is the one we are calling F naught. Then we will get the expected frequency. And this is the one we are calling FE. Then we'll have a column where we have F naught, F naught minus FE. You square this, you divide by FE. Make those ones. Okay, so The observed frequency ya kwanza ni 120. The expected, ukiwa hapo kwa 120, the column is 269 and the row is 219. You divide by the grand total of 566. So what we are saying, hapa, so that one I'll get there. Then I go to 57. When I'm at 57, this is 162 times 219. You divide by 566. When I go to 42, it is 105 times 219. You divide by 566. When I go to 149, it is 269 multiplied by 347. You divide by 566. Ikifika kwa 105, it is 162 times 347. You divide by 566. Ikifika kwa 93, it is 105 times 347. You divide by 566. And then we shall have the total. Are you okay? Oh, you are right. It's not 105. It is 135. So this is 135. Sure, it's 135. 135. So 269 times 219 divided by 566 is 104. Then 162 times 219 divided by 566. You can call it 63. And then 135 times 219 divided by 566. I can call it 52. 269 times 347 divided by 566 is 165. 162 times 347 divided by 566 is 93. And because we have rounded, now easy to round, they should always add back to 566. So here we shall after by subtracting the others from 566. They should go back to the original total. We should go back. So this then should be 89. Should be 89. So sasa hii nayo itakuwa 120 minus 104, you square, you divide by 104. So 120 minus 104, you square that answer, you divide by 104, and get 2. We can confine ourselves to decimals, 2.46. Hii ingine itakuwa 57 minus 63. You square, you divide by 63. So 57 minus 63, you square, you divide by 63. It is 0.57. Then 42 minus 52. You square, you divide by 52. So that must be 10 squared, which is 100 divided by 52, and get 1.92. Then 149 minus 165 squared, you divide by 165. So 149 minus 165 you square, divide by 165 is 1.55. Huyu mwingine 105 minus 93, you square, you divide by 93. You divide by 93. It's going to be 105 minus 93, you square, divide by 93. It's 1.55 again. Then 93 minus 89, you square, you divide by 89. So 90, you square, divide by 89 is 0.18. So you add those ones, 2.46 plus 0.57 plus 1.92 plus 1.55 plus 1.55 plus 0.18, and getting 8.23. Sasa ukishafika hapo, you now go down there and tell us chi-square calculated. Chi-square calculated is this one, 8.23. Then you look for degrees of freedom. Degrees of freedom will be hii table yenye tuna deal nayo, it has 2 rows. So it is going to be 2 minus 1 times, it has 3 columns. So 3 minus 1. So that gives us what? 2. That gives us 2. Then chi-square critical. Chi-square critical. Sasa unaenda kwa tables. Unaenda kwa table on page 56. Page 56. Maybe we needed to have specified our alpha. We are testing at what? 5%. Maybe you unaweza rudi hapa tu useme let alpha to be 0.05. We are testing at 95%. So what you do, unaenda kwa hiyo chi-square huko mwisho on this side, the left hand side, unatafuta mahali kuna 0.05. Can you see it? The column towards the end huko mwisho 0.05. So if you can see it, then go to the degrees. The degrees of freedom is 2. So what is there? 5.99. Then from there you make the conclusion. You make the conclusion. The conclusion is very simple. There is some association since chi-square calculated is greater than chi-square critical. That is 8.23 is greater than 5.99. It's as simple as that. Sababu the calculated is greater, kumaanisha there is some association. Lakini kama ingekuwa less, you would say there is no association. That is how you do the chi-square. So I would like you to do exactly the same thing with question 16. The same thing with question 16. Utengeneza hii table hivi. Observed, umeona ni hizo ziko hapo kwa the table. Then you utengeneza hivi, weke hizi vitu, venye tu nimepaka, pange tu hivyo mbika conclusion. That's all. So we call it a day at that juncture. Then we hope to meet now on Monday, God willing, to look at another issue. Thank you so much and enjoy your day.